Hi, this is Daryl Peterson, and I'm the manager of the Applications Engineering Department at Micromeasurements. I'd like to take just a couple of minutes and answer a very common question we get in the Applications Engineering, which is how do I select the resistance of the strain gauge? You'll find today that there's a broader selection of resistances than there was, say, 20 years ago. You can select a gauge that's 120 ohms, 350 ohms, 1,000 ohms, and in even some applications, we go as high as 10,000 ohms and possibly even higher than that. The vast majority of strain gauges are going to be lower than that. They're going to be around the 350 ohm mark. And I'm going to talk just briefly about how you go about selecting the right resistance for your application and really the types of things to consider when selecting that resistance. So let's get started. So I'm going to put first up here 120 ohms. 120 ohm strain gauges were the value when strain gauges were originally getting developed and getting started. That was the resistance of them. And we still have customers today that you go into their facility and they've been using 120 ohm gauges for many years and they continue to do so and they can work just fine. But let's talk about the advantages of 120. First off, we find that some of the smallest gauges that we make are going to end up being 120 ohms in resistance. So if you've got really tight spaces, small parts, common application I see is like testing gear and trying to put a gauge down at the root of the tooth on a gear, then you might start looking at 120 ohm strain gauges because you're going to find they're going to be the smallest ones you'll see in the catalog. Secondly, and it's not by much, but they have a slightly better fatigue life. It's not really distinguished in our catalogs or in our literature, but if you were to take equal sizes of strain gauges, one in a 120, one in a 350, oftentimes you'll find the 120 ohm gauges will be slightly thicker. The foil will be slightly thicker, not enough that you can see it or anything, but we use a little thicker foil to build these 120s, and in a fatigue test, when you compare the two, we'll find typically slightly better performance out of the 120s. And then the last thing that can affect all of us is typically they are just a little bit less expensive. Not a lot. In general, I'd say probably that's going to run somewhere around about 5%, maybe 5 to 10%. And quite frankly, I would argue that in stress analysis applications, the cost of the strain gauge typically is pretty low on the list of priorities. The quality of the installation, the quality of the gauge, the installation techniques, all that is much more important than a slight price difference of 120 versus 350. So that's really about it for 120. So let's look at 350 ohm gauges. And I'm just going to say and higher. So this could be 1,000. It could be 2,000. It could be 3,000. We sell strain gauges in those values of resistances as well as 5,000. And 5,000 ohms is becoming more and more common today. So when you look at the advantage of a 350 ohm gauge, the first thing that you're going to see, if you remember back to Ohm's law says that the current is equal to the voltage divided by the resistance. And as that resistance value goes up, that current level goes down. So what that means is that there's less current through a 350 ohm grid strain gauge. Now, along with less current, what that effectively means is less power and less heat. So what that allows us to do is to proportionally increase the voltage we use to power the circuit. And what that means is that it allows for higher bridge excitation. And what that means is since we can increase the bridge voltage, we increase the output signal. And if we're increasing the output signal, that means we can get a better signal to noise ratio. So we increase our bridge excitation. That's going to produce more signal out of the Wheatstone bridge, and that allows us to decrease the amplification that we're using. It may be something that's more automated for you if you got a data acquisition system, or if you're using a more traditional signal conditioning amplifier like a 2100 system or 2200 system or 2300 system, then you're going to be adjusting those controls. But as you go up in excitation, you can step down in the gain, and that allows for a better signal to noise ratio. Now also, the lead wires become less of an influence, because now if you look at it proportionally, as the resistance of the gauge goes up, that total percentage of the lead wire resistance relative to that goes down. So lead wire resistance has less influence. So let's say, for example, you've got a strain gauge with maybe 100 feet of cable connected onto it. You probably want to consider going to a 350 ohm strain gauge, maybe even higher, to help to reduce the influence of that resistance from the cable. So in general, if you're testing things like civil engineering structures and you've got long runs of cable, in general, I'd say I'd lean you towards 350 ohm strain gauges. And the last advantage, and I'll write it over here, is since there's less current, because it really ties into that, batteries will last longer. So if your instrumentation is battery powered, and a good example of that would be when you're trying to test things that rotate or spin, in particular at high speeds, oftentimes those electronics are battery powered. You're putting a battery pack on that shaft that's going to rotate, and that's what's going to provide the excitation to the strain gauge circuit. Well, you'll find if you go to a higher resistance gauge, those batteries are going to last longer. We have some applications where we've gone up to 3,000 ohm strain gauges for just that reason, because the customer didn't want to have to go out to the piece of equipment and replace the batteries as often. So instead of using a 350 ohm gauge, they actually pushed it up to several thousand ohms of resistance for that reason. And today we find that higher resistance gauges are more common. We have the ability now to produce strain gauges, again, in resistance values easily to 5,000 ohms, and you're going to see over the course of the coming months, more and more of these higher resistance gauges are going to be released, and it's really for these reasons that we do that. So you may need to take a look at your application, if it's battery powered, if maybe you've got some longer lead wires, or maybe you're finding the noise level is more than you want, and you're looking for methods to try to help reduce the influence of these. You can consider, again, higher resistance gauges. It doesn't have to be 350. You can push it to 1,000. Again, you can push it as high as 5,000. Now, if you'd like to find out more about selecting the right resistance or strain gauges in general, please feel free to reach out to us through the website, which is www.micro-measurements.com, or we have a staff of applications engineers, and we'd be happy to answer any questions for you. Just pick up the phone and dial 919-365-3800 and follow the prompts till you get to applications engineering, and we'd be happy to help you. Thank you and have a good day.